Okay, guys, we're going to go through calculus graphs in general. Now, a calculus graph, it has, most of the time, 7 important points. It has the points that we need to calculate. Okay. The important ones is 3 x-intercepts. Okay. Now, the x-intercepts are most of the time 3, but it can be 2, because sometimes the turning point of the graph can actually turn on the x-line. So this is when you'll see there's 2 x-intercepts. Okay. A lot of the times you'll find sometimes you'll find there's 2 x-intercepts, but most of the time our calculus graphs look like that. There's 3 x-intercepts, right? That's the first one that we need to talk about, is the intercepts. They are always 3 or 2, right? The next one is the turning points. For you guys, the turning points are always 2, right? There is a y-intercept. The y-intercept is always just 1. And there's another point, 3, 4, 5, 6. There's one more point that's called the point of inflection. Now, the point of inflection is not exactly in the center, but the point of inflection shows you from one turning point to the other turning point. So it's somewhere there. You can get it by taking 2 turning points and dividing by 2. Should be okay to find concavity, but to find if something's concave up or concave down, all you need to do is find literally the one point of inflection, and you can work with it, right? So remember, graphs can go down and be concave up, or can go up and be concave down and stuff. So don't confuse those parts, but this is only one point. It's very simple to deal with. Now, each part of this has a certain number of rules that we're going to deal with. If you guys don't have the silver or white calculator, I'll say we're in a little bit of trouble. But in general, we can use the division, the long division method, and this would work out. So the first question is y equals to x cubed plus 7x squared plus 7x minus 15. Okay. Now, the first thing I would like you to do is, if we're going to draw a graph, I think you guys need to find out what is the y-intercept. Step 1, get the y-intercept. The y-intercept is when we let x equal to 0, and this becomes 0 equals to, oh wait, sorry, y equals to 0 cubed plus 7 into 0 squared plus 7 into 0 minus 15. Just like a normal graph, just like the parabola that you deal with, this d value, remember calculus graphs are in terms of ax cubed plus bx squared plus cx plus d. The d value is the y-intercept. So here we can see y is equal to minus 15. And this value is 0 and minus 15, right? Most of the time, they would not make you draw the calculus graph. But the truth is, if they do, you know how to do it. But also, if they don't, you know where every single point comes from. So that's the point of this calculus graph. The next one is the x-intercept. We're going to let y equals to 0. If you don't have this calculator, it's a little bit difficult. This one, I'll do a separate video on the division method. But for now, 0 equals to x cubed plus 7x squared plus 7x minus 15. I would open this up and I would get the answers quite easily. You can press mode equation 4, enter in your 4 values, press equal, and we would end up with x minus 1, x plus 3, and x plus 5. You would not know that, but your answers would be x positive 1, x minus 3, and x equals to minus 5. Remember again, these are not the x-intercepts. The intercept is 1 and 0, minus 3 and 0, and minus 5 and 0. And that's all there is to this part, right? Again, if you don't have the calculator that can factorize, it does become a bit difficult, but I mean, it's like 5 minutes extra. So we got our 3x intercepts, we got our 1y intercept. We need our turning point. So the rules for turning point, guys, the rules are first derivative, solve for x, substitute, and you could give a statement, but it's fine, right? Now, when you substitute into the question. Substitute into the original. So this is y equals to first derivative y prime equals to 3x squared plus 14x plus 7, right? That's fine. We did the first derivative. The next is to solve for x. We need to make this equal to 0, right? Thereafter, we need to use the minus b formula, or you can simplify with your calculator, but the minus b formula in general. We end up with x equals to minus 0.57 and x equals to minus 4.1. Right? Now we need to substitute. Please don't substitute into the first derivative. It's going to cause a bit of problems. Substitute into the original. Y equals to x cubed plus 7x squared plus 7x minus 15. Let's actually substitute one time, right? This is minus 0.5 cubed plus 7 into minus 4.1 squared. Oh, wait, sorry. 7 into minus 0.57 squared plus 7 into minus 0.57 minus 15. And this answer should equal to y equals to minus 16.9. Now, when we do the exact same thing for the other side, we end up with two answers. Our turning point is at minus 0.57 and minus 16.9. And the next one is at minus 4.1 and 5.05. I know this got nothing to do with the question, but in terms of maxima and minima, this would be the min because it's the lowest turning point, and this would be the max because this is the highest turning point. So it's a bit difficult at the start, but once we understand the rules, it's okay. Again, I highly doubt they're going to make you draw a graph, but if they do, at least we know where the points are coming from. So the turning point was quite simple. And okay, turning points there, and thereafter, the last one is the point of inflection. Now, guys, this point of inflection is important. The concavity is important, but it's very simple as well. All we do is the rules for this is calculate the second derivative and solve for x. Solve for x and sub x into the question. Okay, let's try this from the start. Let's get it right. So that's y prime equals to 3x squared plus 14x plus 7. If we do the second derivative, that'll be 6x plus 14. Let's make it equal to 0. And if we solve, we get basically minus 14 over 6. Minus 14 equals to 6x divided by 6 divided by 6. X equals 2 minus, well, 2 and 1/3, right? Or if we're drawing, see guys, if you're writing points in calculations, fractions are the best. If you're Giving you writing the points in any sort of calculation, fractions, mixed numbers, those are good. Generally, I would prefer this for calculations. It's just easier to write in the calculator. It takes less time. But what happens when you start to plot? When we start to plot, we need to use, I think decimals are easier. So when you start to plot, use the minus 2.33. That's better. But it's fine. Last step, substitute this answer into the question. That's cubed plus 7 into minus 14 over 6 squared plus 7 into minus 14 over 6. That's minus 15. And this answer is, if I'm not mistaken, just give me a moment, minus 5, 25 over 27. Okay, cool. I'm going to use this as minus 5.93. Okay, I'm going to use that as minus 5.93. It's easier for me to deal with. This is minus 2.33, and this is minus 5.93. Now that we've got all 7 points, it's very simple to draw the graph. I'm going to struggle because of my graphic tablet, but I'm going to take the marking guideline and just put it on the screen so you guys have a neat graph to learn from. And generally, questions like this are not too difficult. So the graph generally looks like this. I would never be able to draw this without a ruler or pencil and a book. But our x-intercepts are year, year, and year. Our y-intercept is here, minus 15. Our two turning points are here. And this point is very important. This point is the point of inflection. Okay? Is a point of inflection. This, I'm going to show you guys in a theory lesson how we deal with stuff that's concave up and concave down. But also this helps us with the shape of the graph. It goes from one turning point to the other turning point, and we can just go. So even though the graph's going down, we're going to look at the shape of the graph at a later stage. Or even though the graph's going up, I'll show you guys how to deal with concave up and concave down. So all we do is we look at the point of inflection and we look at whether the graph's going to be a happy face, or even if it's going up, whether it's going to be a sad face. That's what actually matters, but we'll deal with that at a later stage. Okay, so we're going to do one more graph just as practice before we move on. Step 1 is to calculate the y-intercept. So to calculate the y-intercept, we let x equal to 0. One of my students is going to help. By if we let x equal to 0, what do we get?
Negative 48.
So we get negative 48. And the thing is, this negative 48 is just the y value. It's not the point that we plot. So when we deal with the y-intercept, we get 0 and negative 48. Okay, so that's one mark gone. I'll be happy with that. If we deal with the x-intercept without the calculator, this would be x cubed plus 13x squared plus 34x minus 48. So now the x-intercept, we have to let y equal to 0. Sorry. This is x cubed plus 13x squared plus 34x minus 48. If we simplify this with the calculator, it's fine. Without the calculator, it might be a tiny bit difficult, but we can factorize it, right? I'm going to help with this one. But now this is x minus 1 as a factor. And this would be x squared plus 14x plus 48. Okay, this cubic functions, to be honest, if you go and look at any of the grade 10 cubic function videos, it can be factorized as well. There is a formula, if I am not mistaken. Yeah, this can be factorized as well. I think I would do a shortcut video for you guys on how to factorize this, but we can deal with this one, right? Okay, so this is x minus 1, and then this would be x plus 6 and x plus 8. This would be x equals to 1, x equals to minus 6, x equals to minus 8. Again, these are not our x-intercepts. Our x-intercept is 1 and 0, minus 6 and 0, and minus 8 and 0. So that's fine. That's two parts that I'm happy with. 1, 2, 3, 4. So we got 3 more points that we need to do, and we need to draw the graph. Okay, so for those of you that don't know how to factorize cubic, we can do division or the calculator. Calculator is mode, equation, and I think it's 4, if I'm not mistaken. You enter the values in and we're done. It only works with the 991 calculator, so if you don't, it has to be division for you. But if we deal with the turning points, what would the first derivative be?
The first derivative would be 3x
3x squared
26. Yes.
plus 26x
And
plus
34.
34. Well done. And if we let this equal to 0, and we use the minus b formula, what do we get when we solve this part? So we get minus b plus or minus the square root of b squared minus 4ac all over 2a, right? After substituting, what do we get for x and... Right, guys, again, you could use your calculator as well.
I got negative 1,60, and then negative 7,06.
Negative 7,06. The last step would be to substitute. I was going to say sacrifice, substitute into the original question, guys, not into the first derivative. Don't make any mistakes with that one. Then you're going to get a very ugly graph. Okay, cool. This answer would be? And don't forget to substitute both as well. Okay, so I got yeah.
I got negative 73,22.
Okay, and the next one?
Yeah. I still have to do that one.
Okay, let me help with that one, right? This one I got basically 8. Most likely 8-ish, right? Around 8. Now what's going to happen is the last one, the one that helps with shape, would be the point of inflection. Now the point of inflection is equal to y equals to x cubed plus 13x plus 13x squared plus 34x minus 48. The first derivative, as Bayer gave us, was 3x squared plus 26x plus 34. The next one is 6x plus 26. If I let this equal to 0, I get 6x plus 26. That's minus 26 equals to 6x divided by 6 divided by 6, and x equals 2. Minus 26 divided by 6 is minus 4.33. Okay? You'll help me here, Baya. If I substitute minus 4.33 into, this is 333 recurring, right? But if I substitute this into there, what do I get?
I got 424,14.
100. That's a very, very high number, but I'm not saying you're wrong. It's just that 400. Why did I give you guys a... Oh, wait, what did you get?
It's actually negative 32,7, sorry.
32.68. That's a better number to deal with. But I think it's my fault. I think because of the square. Minus 4.33 and minus 32.61. You know why I was laughing is because as a punishment for my students, I had this graph where like it goes to like 200. It goes to 200 and I think it goes to 500. And I was just making them draw it as when they didn't do the homework. But now this graph looks like this one. So this graph looks like this one. And this is easy to draw when you have your ruler, pencil, and a book. Generally, we look at our points. We have x-intercept 1, 2, 3. That would be plotted first. Generally, I would plot the turning points next because I would go and just do a turning point there. I would do a turning point there, right? Then I would plot my what do you call it, point of inflection. I would join there. I would plot my y-intercept and I would try and join that. And then it would be very simple to draw, right? There are some very funny graphs, stuff that you guys would struggle with, but generally all the plotting is the same. Plot the x-intercepts, plot the turning points, try and join the turning points and the x-intercepts and then connect it to the point of inflection. Should be easy to draw. Let me take out my ugly drawing because their drawing is actually quite good. But that's all there is for this part.